For this lesson, we're going to pick up where we left off with decimals, fractions, and order of operations. We will be adding, subtracting, multiplying, and dividing decimals. Here I've listed a few steps for you to use when you're adding and subtracting decimals. The most important thing here is to make sure that the decimal points line up vertically. A few examples here. Notice in the addition example, there was a 0 put in as a placeholder so that all of the numbers would have the same digits. Then the decimal points are lined up, and then we will add as usual. Then steps for multiplying decimals. Here the most important thing in multiplying decimal is that the decimal in your answer is going to be the same number of total decimal places that you have in your problem. We start from the right and count back to the left to find the appropriate place for the decimal. In this particular example, we have one decimal place in our original problem. So when we multiply it out and we get our answer will have one decimal place. Multiplying by powers of 10. So when we're multiplying by powers of 10, such as 10, 100, 1000, we're going to move the decimal point to the right, the same number of places as there are zeros in the power of 10. Then if we're multiplying decimals by powers of 10, such as 0.1, 0.01, etc., then we're going to move the decimal point to the left, the same number of places as there are decimal places in your power of 10. Some examples here, we'll see in A, we're multiplying times 100, which has 2 zeros, so our decimal place will move 2 places to the right. When dividing by decimals, the important thing is that the answer in your quotient, which is the answer that goes here, lines up, the decimal point needs to line up with the decimal in the dividend, which is here. And then we divide as normal. When we have a division problem that is written horizontally, we want to make sure that the number that comes after the division sign is the number that's going to be outside of the division bracket. When dividing by powers of 10, such as 10, 100, 1000, in dividing decimals, we want to move the decimal point to the left, the same number of places as there are zeros in the power of 10. Our example here, we have 29.5 divided by 1000. So we have 3 zeros. So we want to move our decimal 3 places to the left. Exponents. In dealing with exponents, basically it is a shorthand way to write repeated addition. In exponents, we have the big number, which is called our base, and then we have the small number up to the right, which is called our exponent. The exponent tells us how many times we're going to multiply the base times itself. So in this particular instance, we would be multiplying 3 times 3 times 3 times 3 times 3. In these examples, we need to rewrite our problem with an exponent. This is called exponential notation. Notice in the second example, we have 2 different bases, so our answer will have 2 different bases. Evaluate. To evaluate an exponent, we are going to multiply the base as many times as the exponent tells us. In this case, 4 times 4 times 4, multiplying it out gives us 64. If we look down where we have a power of 10, our answer is going to have as many zeros as the exponent is. In this case, the exponent is 6, so we will have 6 zeros in our answer. Order of operations. Remember, order of operations deals with PEMDAS, parentheses, exponents, multiplication and division in the order that they occur from left to right, and addition and subtraction in the order that they occur from left to right. Here there are 4 examples given. I will walk you through the first one, and then the last 3 are actually written out for you. If you have any questions, feel free to ask. For example A, according to order of operations, we need to do division and multiplication in the order that they occur because we don't have parentheses or exponents. So 8 divided by 2 will give us 4. Then we'll bring everything else down. So plus 4 times 4 plus 7. Next, according to PEMDAS, we'll do multiplication. So we'll bring down the first 4, multiply 4 times 4, which gives us 16, and bring down the 7. Now we have all addition, so we can just add and we get a total of 27. You can go through examples B, C, and D and let me know if you have any questions. To evaluate an expression, we substitute in the given value for each variable. In this example, we have C equals 1 and D equals 4. So we're going to plug in 1 for C as we did here, and we're going to plug in 4 for D. Going back to using PEMDAS, our order of operations, we need to do our division first. So 28 divided by 4 gives us 7, plus our 1 gives us a total of 8. In this example, remember when we have a number and a variable side by side, that means multiplication. So you will have 4 times G, and in this case, G is 5. Fractions. Here we're dealing with exponents and fractions. So once again, the exponent is going to tell us how many times we're going to multiply this fraction times itself. In this case, it would be 2/3 times 2/3 times 2/3 times 2/3 to give us a total of 16 over 81. Here we will use order of operations to evaluate these particular problems. I will walk through problem A with you, and then you can work through B and let me know if you have any questions. For A, order of operations tells us that we need to do our multiplication first. So multiplying, we just multiply our tops times our bottoms, so we'll have 5 over 24. Bring down our 3 over 8, so we have 3 over 8 minus 5 over 24. In subtracting two fractions, we always need to get our least common denominator first. In this case, it's 24. Then we need to get our equivalent fraction for 3/8 with a denominator of 24. So in doing that, we know 8 times 3 gives us 24, so we need to multiply 3 times 3, which gives us 9. Now we can subtract, get 4 over 24, and simplify that to 1 over 6. You can walk through this example and let me know if you have any questions. Just remember that dividing two fractions, we need to keep switch flip. So we keep the first number, change division to multiplication, and flip the second number. Converting fractions to decimals. We have 2 types. The first one is terminating decimals, which is basically a decimal that ends. So this decimal has a finite number of digits. Then I've given you some steps to take. The important thing here is you're going to continue dividing until you have a remainder of 0. Looking here, we have 9 over 24. The denominator is going to be the number that goes on the outside of the division bracket, and then we just continue to divide through until we get a remainder of 0. Then we have repeating decimals. These are decimals that have a digit or a block of digits that repeat over and over again. Here, walking through this example, we do our division and we'll notice that the 3 starts to repeat. So our answer would be 1.83 with the repeating bar over the 3. If you have any questions, please feel free to email me or ask them in class. Thank you.